joining the ENS Integration Workshop. Joining us today is Makoto, who will be taking us through a couple cool things. And yeah, feel free to ask any questions at the end of the session. There will be enough time for that. And with that, I will hand it over to Makoto to introduce himself and kick the session off.
Hello, hi, thank you, Emily, for introducing me. So my name is Makoto, and let me share my screen. So my name is Makoto, but also in ENS world, also known as Matoku.is. And make this slide. Okay. So, Happy New Year, everybody. It's great that everybody's, New Year just got started. And now already excited to hack on new stuff, especially for around the NFT. And so for ENS, we have a small prize of $150 worth of ETH to each of the 5 best projects to use ENS. And this can be basically ENS username, avatar support, name resolution for entering a crypto address or hosting your website on ENS and the distributed file network. So basically, yeah, you can do whatever the hack you want to do, but you might want to integrate with ENS to qualify for our prize. And if you just want looking for a quick pointer, if you go to, I think this is the URL, but if you go to docs.ens.domains or join our Discord channel, NFTHack has its own Discord channel, which I will be checking from time to time. But we also have our own Discord channel, chat.ens.domains. And I think there's a channel called Developer. If you ask a question there, someone apart from myself might also answer, our community members. But like most of the stuff, you look into docs.ens.domains, you can find the information. And also we make, as you may know, we turned into DAO and we're trying to decentralize more things. And one of the stuff we've been trying to change is previously any protocol related to ENS was part of the EIP, Ethereum Improvement Protocol. Now we're trying to be independent on our own. So all the majority of protocol related to ENS is now in docs.ens.domains ENS improvement proposal from 1 to 10. So most of the in-depth of how things are working, if you look into these protocol proposals, you can find more detail. And in terms of the integration, again, if you go to, I think if you look into the ENS library or working with ENS section, you can find most of the examples. And the important thing is, for most of the simple usages, the JavaScript library or like Python or Java library, which you use to interact with Ethereum, most of them have ENS support built in. And we have our own library called ENS.js, but it's getting a bit out of date. And currently, I think for most of the simple usage, ESA.js has a most up-to-date support. So I highly recommend using them. But also there's a framework like Waffle, Embark, Scaffold.s. They also have an integration with ENS. And throughout this workshop, I'll use this example as a reference. And in this agenda, I'll first walk you through for ENS Integration 101. So if you integrate any of things mentioned here, that's kind of minimum you need to do to kind of qualify. But this is NFT hackathon, and I think we've been promoting ENS as a Web3 username, and where avatar takes a big part. So I'll go a bit deeper on how ENS avatar works under the first. So if you want to kind of not just integrating, but you want to do something cool related to ENS, probably you can find some interesting information here. And lastly, if I have some time, I'm going for going through a couple upcoming features. Unfortunately, these features are not ready yet, but you can kind of have some expectation of what things are to come in near future. Okay, so with this in mind, first one is ENS Integration 101. And the most basic feature of ENS is called for lookup. So that, for example, my name is matoku.is. So if you want to send me some ETH or ERC20 to me, you go to, for example, MetaMask, or you can go to ETH account and you type matoku.eth, and then boom, you get a hexadecimal ECM address. So this is the most basic feature. So if you have some any of your dApp on the application, if you have to find some address, you can have like ETH name, or you can have like ECM address, which probably people would copy and paste, or you can put .eth address. One important thing is ENS is not just about .eth. We also announced integration with DNS names. So if you have something like matoku.com, you can use ENS matoku.com as a ENS name. How to do that is I didn't cover in this documentation, but you have to bear in mind that it's not just .eth. So don't just like some hardcore .eth name. And yeah, to get the get address. So this is example of Web3.js. If you do ens.get address alice.is, and you get the hexadecimal addresses. So that's the most basic integration. The next step is we used to call it reverse lookup, and most people didn't understand what it is. So now we kind of rebranded it as kind of primary ENS name. So you may set multiple for lookup to point like 3, for example, ENS name both to one single ECM address. But by using this primary ENS name, you can let dApps know what your primary ENS name is. So in this case, if I log into Uniswap, the dApp knows which username I'm logged in as. And to set it up from the our application ENS app site, if you go to my account, if you click my account, and it has a drop down of the list of names that ECM address owns, then you just select. So that's how most users sets primary name. And for dApps to actually use that feature, again, this is from our documentation side, and in this case, it uses example of ether.js, and what it does is like provider.lookup address, and if you pass that address, it returns the name. Important thing you have to do is, so this address let anyone to specify any names. So it doesn't prevent me from just saying my ECM address points to vitalik.is. So it's important to validate, to do the both reverse primary ENS name lookup while doing a for name lookup to say that this address points to matoku.is and matoku.is points to this address. By doing the bidirectional setting, then you can verify that this address belongs to this name. Luckily, ether.js does that underneath. So if you're using ether.js, you don't have to worry about it. But if you're using other libraries, or if you're directly interacting with our smart contract, you have to do that bits. Okay, and the last bit is about web, decentralized web. Is that so if you have for example, quite often, most dynamic logic is in a smart contract, and you have a kind of HTML or CSS and JavaScript images on the front end points to the smart contract. Then in that case, this front end has can be all kind of bundled up and put it into the IPFS decentralized file storage. So what you can do is once you upload these asset files in the IPFS, you can also do it with Swarm and the others as well. You can basically set the basic decentralized file system generates so-called content ID, which is a hash of the entire assets uploaded into IPFS. Then if you set that into the section called content hash in the ENS, you can actually point the websites to your ENS name. If you use something like a MetaMask or I think Opera, and it does it natively, but we also provide a .eth.link so that, for example, in this case, the name is app.ens is. If you type .link, it resolve to the website. So it displays the IPFS hosted distributed website. There's also another one called .limo. So if .eth link is unstable, you can also serve a file at the eth.limo. Okay, so that's a kind of basic use, but very basic usage. And now I'm going to talk a bit about ENS Avatar, which you might have seen that like if you go to OpenSea and if you go to type matoku.eth, this is an ENS name, but you can also see my NFT, which I set on ENS. And other dApps can actually use the avatar information when displaying an ENS name on their site. So this is an example of the 1inch. And if you're not interested in how things work underneath, but if you just want to do that integration, there's a third-party library called dev, I don't know how to pronounce this, Davatar/React, which provides a React component so that you can just provide an API key and the address, and it does look it up and it also display. So this is the easiest way to just integrate. But if you want to understand a bit of internal, this kind of takes you to how ENS works. The ENS is just like any other kind of, the dApps. It's just another collection of smart contract. And most of the dApps, when you integrate, you are interacting with a smart contract called ENS registry, which is basically the gigantic phone book where it has a key as your name and the value as an address. But instead of the registry contract contains the address information, it actually has a map to something called resolver, which is another smart contract. By doing this, and the resolver has a logic to contain the address value information. So the reason why we do this is that it makes it easier for us to upgrade the logic, so that when so this is a flow that when you first says, hey, give me the address of foo.is, registry returns 0x1234, which is a resolver address. Then underneath on all these libraries, we ask okay, what's the address of the foo.is? Then resolver has the information and return it. And the reason we do is make this, it makes it easier for us or anyone to add a new address record type, so that I already introduced ECM address type, and then you can set a content hash for the website. There's already support to put public key or ABI or multi-coin, which is a Doge or a Bitcoin. These things actually, multi-coin didn't actually initially exist, but by doing this kind of 2 steps, you can change the resolver smart contract to the more up-to-date one, or you can actually write your own resolver and add your own arbitrary logic. So that's why it has in a kind of 2 steps. And resolver. And the reason why I mentioned this is one of the feature is to be able to set arbitrary key and value text, so that, for example, in iam.ice.is, you can set a key called test and set the value called test record. So you can almost use as your own dictionary set. And this avatar specification, which I showed, avatar, which I showed you earlier, is one of the specifications just using this text record with a key called avatar. And we still haven't fully formalized this full format. That's why it's in just a gist of the ArcNet, which is Nick Johnson, who is the founder of Ethereum name service. But the basic idea is like, this is my Matoku.is ENS app page that you can see that it says EIP 155 colon 1 is a chain ID, basically, which is mainnet, and then slash ERC 721 or 1155. Then it puts a contract address of the collection of the NFT, then token ID 9421. So by doing that, it basically contains the full information about the NFT. So from the app level, you can actually basically figure out whether this token is owned by this address owner of the Matoku.is. So by turning that into the code, it's going to look like this. So first you get the resolved name, owner, and then one important thing is, so quite often most of NFT has token ID as some random number, one like punk 235 or something. In our case, our token ID is a label. So if you say hash of the label and turn into the integer. So first you use the library called K256, basically SHA-256, and but like you hash the, for example, if there's a name Vitalik.is, you hash Vitalik part. Then you turn it into the integer and you get the token ID. And by looking at because it's just ENS is another 721 contract, if you check the owner of that token ID, you can figure out whether the address is the owner of the token or not. But by doing this all, you have to write 5 lines of code. We have metadata information of our ENS.eth name as API. So if you go to metadata.ens.domains, and I think you have to put like chain name, like main name /avatar/matoku.is meta, you can find all the information related to ENS as an NFT, including whether it's owner or not. So that's, you could make use of this API to do something in your hack. And also, if you go to metadata.ens.domains/docs, there's an API documentation, so you can find more detail about the spec. And I think so that's it for the avatar. And I have 10 minutes left, so I'll just go through these upcoming features. And so first one is called subdomain as NFT, and second one is about LT integration. So this one is also known as name wrapper. So all the avatar specification I mentioned, that's, you can set avatar to any domain, including subdomain. By the way, subdomain means like, for example, .eth is TLD, top level domain, and secondary is like, for example, Matoku.is. I can, as an owner of Matoku.is, I can keep creating a subdomain like foo.matoku.is, bar.matoku.is, and I can create some subdomains. Important thing is currently only Matoku.is is NFT in one collection, but subdomains are not NFTs. You can do it, for example, Decentralized. The Decentralized avatar has a, I think, ENS name called .dcl.is, and dcl.is has avatar name. So I think I have like matoku.dcl.is, and this subdomain is also NFT. But if you want to do that manually, I think what you have to do is basically you create a NFT collection as a smart contract, and then when you mint, you also have to kind of call ENS registry to create subdomain as part of the mint. So you have to kind of do it, write its own smart contract, which you can do. And I think if you want to see the detail, you actually go to the controller of the DCL.is. And if you go to Etherscan, you can actually see the source code, so you can read it there. But name wrapper is kind of ways to automate it. That like if you wrap your name, for example, Makoto.is, any subdomain underneath automatically becomes NFT on its own. So that's a new feature. It's actually, we've been saying new for a very long time that this contract has already almost complete, and the audit is complete as well. So we are just waiting for us to integrate, deploy the contract and integrate with our front end. That's the only reason we haven't done it yet, but it's pretty much there. So if you really want to, I think there's one project called Sysmo. I think they actually test deployed by themselves. So if you are a brave one who want to try out, we have a repo called ENS contract, which has pretty much all the contracts related to ENS. And if you go to wrapper, there's a contract there. But you have to deploy by yourself. So that's a subdomain as an NFT. Second part is called L2 integration. We used to call it during, but we rebranded to CCIP read in partnership with a Chainlink. So now the repo is in under github.com/smartcontractkit/CCIP read. And I don't go the full detail, but the idea about the CCIP read on our approach is so that in the resolver, I mentioned that if you are the owner of Makoto.is, you can change resolver. So the idea is we provide a new provider called CCIP read provider or something like that. By doing that, this provider resolver, currently it returns the Ethereum address, but our proposal is for this resolver to return HTTP endpoint called gateway, where you can call that gateway, and then gateway fetch the data on your behalf. And if it's a L2, you can use that information to verify the state on L1. And then the big picture idea is that we don't pick the winner yet because there's so many chains coming up. So it's going to be you who decide, okay, I want to issue subdomains under Arbitrum. Then I mentioned it as a Reddit because Reddit, I think, announced using Arbitrum. Then you set the resolver of the Reddit points to Arbitrum and issue subdomain underneath. Whereas, for example, like DYDX, who's already in Starkware, if they want to issue a subdomain, they set the point the resolver of DYDX to go to gateway, which fetch the data from Starkware. We are all talking to all these Optimism, Arbitrum, Starkware. We're all talking to them how we can work together. It's still not ready yet, but we're working with them, and so that you can pick the L2 of your choice. So that's a big picture. This one is still a bit slow. We try to have something out by the end of this quarter. But I think if you wanna get up to speed, CCIP read repo is where all the information is. And I think just for the recap, so we have for more information, you can check Medium, or ENS, you can follow Twitter, ENS Domains, or chat ENS Domain is our Discord URL, and the ENS Domain is our website. Thank you very much. Okay, so I have 2 minutes left, so maybe I don't have time to answer any question, or I might be able to. I think there's no comments on the YouTube section, so okay.
Yeah. I've also saved the Zoom chat, so I can post a lot of these questions in the sponsor ENS channel for you to answer async. Maybe you can just answer the first question in the Zoom chat, and then we'll have to close out the session because the next workshop is start.
Okay, so is in the back end, is this a simple mapping from name hacks address? So I think this, I kind of answered the question, like it's like there's a registry and a resolver. So registry store the name and another smart contract. And the smart contract, resolver smart contract is in charge of returning address. When it comes to layer 2, it's going to be, there will be another step of like a resolver points to gateway URL, and the gateway is in charge of returning the data. I think, that's it.
Great, thanks so much, Makoto. I will relay these questions in the sponsor ENS channel. So if your question was not answered on the workshop today, it will be handled in Discord. Thank you so much for the really great session. And I hope everyone has a really great day.